I welcome all of you to Pune College of Arts, Science and Commerce, Camp Pune 1. Myself, I am Dr. M.B. Pathan. I teach Statistics Paper 1, Discrete Probability Distributions and Time Series. Last time we have seen the introduction to truncated distributions, and we have seen the general definition to write PMF for truncated random variable. It is a ratio of original PMF divided by 1 minus probabilities belongs to the truncated values. I had given you the situations where you can think to apply truncated distribution. If the range of variable in the real life, some part is not observable, but experiment satisfies the characteristics of certain distribution, then we think about truncated distribution. Yesterday I had given you definition of truncated binomial distribution. That is, the numerator is binomial PMF, and we study binomial by truncation of beginning value at x equal to 0. So we wrote the PMF of truncated binomial random variable as NCX p raised to x q raised to n minus x divided by 1 minus probability at x equal to 0. At x equal to 0, if you try to find the probability, in the numerator we replace x equal to 0. So we got answer q raised to n. And with the help of this truncated PMF of binomial, we calculated truncated mean. And we got the answer, mean of truncated binomial random variable is NP divided by 1 minus q raised to n. After this derivation, I had given the remark that truncated mean always greater than original mean of the binomial distribution. Today, we'll try to proceed ahead by calculating Today we'll try to see variance of truncated binomial distribution. Okay, are you looking my screen?
Yes, sir.
Okay, today we'll try to develop variance of truncated binomial distribution. Let xt follows truncated binomial distribution. We find its variance by the definition of variance xt equal expected value of x square t minus square of expectation. We developed expectation of xt, the square is not there. In yesterday's lecture, that is np divided by 1 minus q raised to n. So this quantity is going to be replaced at second place, and then we make a square. So to get the answer of variance, we need to calculate expected value of x square, and that will be derived as e of x square, e replaced by summation, curly bracket, x multiply x minus 1 plus x into probability of truncated binomial variable. If you simplify this curly bracket, the answer will come x square. So I split this in two terms, x into x minus 1 multiply probability plus summation x into probability. So we get the answer of expectation of x square by making two calculations. This is number 1, that is your I, plus this is your number 2. So to develop expected value of x square, we have to perform two separate calculations. But if you look number 2, it is just mean of the truncated variable, summation x into px. So this answer is with you, and that is nothing but np divided by 1 minus q raised to n. So just now we want to develop number 1 because number 2 is with us. Let us see how to get number 1. Summation x into x minus 1 into probability of truncated binomial. I put the formula of this truncated binomial, ncx, p raised to x, q raised to n minus x, total divide 1 minus q raised to n. After this 1 minus q raised to n is a constant term. You can put it outside the summation. So we get next page, 1 upon 1 minus q raised to n summation x into x minus 1 ncx p raised to x q raised to n minus x. Now here I apply the result of combination that is very important to remember. X multiply x minus 1 multiply ncx. Write the formula of ncx, that is n factorial divided by x factorial into n minus x factorial. X factorial is written as x into x minus 1 into x minus 2 factorial. X minus 1 cancel with this. And the remaining terms are arranged by this way. So what is your task? You have to prove this quantity is representing this much. X multiply x minus 1 into n choose x will be written like this. So I will advise all the students, make an exercise for this on the rough page and try to prove these three products is same as this 3 product. In the next line, n minus 1 are constant without x, so you put it out. Summation n minus 2, choose x minus 2, p raised to x, q raised to n minus x. Now here I make a second adjustment, p raised to x multiply p raised to minus 2, and here p raised to plus 2. Plus 2 cancel with minus 2. So same term as this. There is no difference here. Now this p square, I put it out. P is a common base. You can add the power, so you get x minus 2. Why I do this? Because it is the requirement of binomial theorem. According to this combination, one constant carries this as a power, another constant carries subtraction of these two quantity. So n minus 2 minus x minus 2 is nothing but n minus x. So no change here. This adjustment, that means I multiply by this and this to get such type of power, which is a requirement of binomial theorem. Now what is the answer of this entire square bracket? According to binomial theorem, this is nothing but p plus q, and power is addition of these two, that is n minus 2. But what is p plus q? We know probability of success plus probability of failure always 1. So 1 to the power anything is 1, so you can drop this quantity. Therefore, I got expression for 1, that is n multiply n minus 1 p square divided by 1 minus q raised to n. Now after this, we write expected value of x square 1 plus 2. First expression we derived, we put it here, plus second is nothing but mean of truncated, which already we got. So np divided by 1 minus q raised to n. So this is a common LCM, you can add the numerator. So I got expected value of x square in this form. Our aim is to develop variance of truncated binomial. This is the definition, expectation of x square minus square of expectation. This is your first quantity, put it here, minus e of xt, this much, square of the bracket. This is the final answer for variance of truncated. But we'll try to simplify this to little extent to get a compact answer. So what is that? I took square inside the bracket, n square p square 1 minus q raised to n power 2. Now from here and here, np is a common. Here np, here np, here also np. So take it common. Here 1 minus q raised to n, 1 minus q raised to n power 2. So one bracket taken out. So what is remain? N minus 1 p. This taken out, so 1 remain. This is a square, 1 is out, so np remain. From this, 1 bracket out, so 1 bracket remain there. Let us take now 1 minus q raised to n as a LCM for entire quantity. So n minus 1 p multiply 1 minus q raised to n plus 1 minus q raised to n minus np is a numerator. Divide by 1 minus q raised to n. Now go on simplification and you will get the simplified expression. for the variance, which is by making a simplification with cool mind, at the last, you will reach here. So this is the variance of truncated binomial random variable. NPQ is the original variance without truncation. You know from your first year. This is the extra quantity which comes in the variance of xt. Let us put the remark, variance of truncated binomial is smaller than original variance. It is the reverse of mean. Yesterday I said truncated mean is bigger than original mean. What about variance? Variance is not bigger. Truncated variance is smaller than original variance. This to be remembered. So I put a question on this. Define a truncated binomial distribution. You have to write the formula, which I told yesterday. And after having a definition of truncated binomial, try to derive mean and variance. It is a theoretical question may ask on this topic. We'll try to study some numerical problems. Example 1. If capital X is a truncated binomial random variable with parameters bracket small n equal to 5 and p equal to 1 by 3. Variable is truncated at x equal to 0. That means 0 value is discarded. Find probability of truncated at point 2. Probability truncated variable taking greater than equal to 3. Expected value of truncated random variable, that is the mean. Variance of truncated binomial random variable. Bit number 5. Verify the relation truncated mean greater than original mean and truncated variance is smaller than original variance. So this example will try to explain everything what I taught yesterday and today related with truncated binomial. Let us proceed how to solve. Solution: xt follows binomial n equal to 5 and p equal to 1 by 3. So I write truncated distribution, PMF of truncated variable. Probability xt taking value x, n choose x, p raised to x, q raised to n minus x. Total divide 1 minus probability at x equal to 0 because 0 is truncated. How I get this number? It is from the numerator. Replace x as 0. NC 0 is 1. P raised to 0 is 1. Q raised to n minus 0 is q raised to n. That comes here. What is the range of truncated binomial? After discarding 0, it begins with 1 because 0 is not observable. 2. The last value of binomial is small n. In this numerical example, we have n equal to 5 and probability of success is 1 by 3. You know q is 1 minus p, probability of failure, that is 2 by 3. Replace these values in this formula, you get a function of your problem. That is nothing but 5 choose x, 1 by 3 power x, 2 by 3 power 5 minus x, 1 minus 2 by 3 raised to 5, x begin from 1 till 5. Now what is the bit number 1 asked in the question? From this formula, what is the chance your truncated variable takes value 2? So this is the probability function for any value of x. I want answer for 2, so just replace here 2 and get the answer by scientific calculator. Answer is 0.3789. The next is bit number 2, probability truncated binomial taking value greater or equal to 3. Now if I want to calculate this directly, I will add probability at 3 plus at 4 plus at 5. That is also true. I can use alternative approach of complement theorem. 1 minus probability complement of this. So it is a greater, so complement will be smaller. It is equal here, so here will be not equal. So I want 1 minus probability x takes value less than 3. So less than 3 for truncated variable, only 2 numbers comes. So this gives a small calculations. Calculations are reduced. So I will use complement theorem. 1 minus curly bracket, put x equal to 1 here and get the probability at 1. Then put x equal to 2 and get the probability at 2. So this is probability at 2. This is probability at 1. Simplify, you get a final answer for bit number 2. Now next is third part. You want to find mean of truncated random variable. This is the formula of truncated mean, np divided by 1 minus q raised to n. Replace only values and get a simplification. Answer is 1.9192. What is it? This is a truncated mean. Now you know from first year, mean of binomial without truncation is NP. N is 5, P is 1 by 3, 5 by 3. Simplification is 1.666. Easily you can see truncated mean is bigger than original mean. That is the verification. Now bit number 4, you want to find variance of truncated binomial. Formula is NPQ, 1 minus q raised to n whole square, in bracket 1 minus q raised to n minus 1, bracket np plus q. Replace the values in proper place, get a simplification, and you get answer of variance of truncated binomial with given parameter is this much. Let us see now what is the variance of original variable. Variance of binomial without truncation, that is NPQ. Put the numbers and simplify. You can see variance of truncation is 0.79 and without truncation is 1.11. That proves variance of original variable bigger than variance of truncated variable. Whereas in case of mean of truncated bigger than original mean. That is the reverse way. So you have to solve numerical problems related with truncated binomial by this way. Let us take one more example for getting clear idea about truncated binomial random variable. Example 2. Suppose number of peas in a pod follows truncated binomial distribution, which is truncated at x equal to 0 with parameter 6.7. Find probability that pod will contain at least one p, pod will contain at most 5p, pod will contain exactly 3p's. These are the different probabilities which is to be calculated. Bit number B, find average number of p's in a pod. That is expected value. When I say average, that means expected value. Find standard deviation of number of p's in a pod. That means get a variance and after that get a root. That is standard deviation. Bit number D, draw sketch of PMF for your random variable which is truncated at 0. State value of mode by looking sketch of the graph. See now how to proceed. Bit number A is same as example 1. Write the PMF and use PMF to get this calculation. This is also similar, get the expected value. This is similar because once you get variance, you get standard deviation. This D and E is a new to you. See how to proceed. We have truncated random variable follows binomial distribution with parameter 6.7. Further, random variable x is truncated at x equal to 0. So we have formula of distribution original binomial divided by 1 minus q raised to n. X begin from 1 to n. Here n is 6. So 1 to 6. N equal to 6, P is 0.7, Q is 0.3. Put these values in this formula, you get probability mass function of your random variable xt. We have bit number 1. Probability pod will contain at least one p. Now, when I say at least, that means minimum 1 or greater than 1. So, probability xt greater than equal to 1. What are the values for this? Greater than equal to 1, it may be 1, 2, 3, 4, 5, 6. Because maximum p's are 6 in a pod. So, I have to make addition of 6 probabilities. I can reduce my calculation by result of complement. 1 minus opposite of this. Xt greater will be become smaller. If it is equal, it will be not equal here. So 1 minus probability xt less than 1. Xt less than 1 means what? Xt less than 1 means 0 value. But we are studying a truncated binomial which does not observe 0 value. So this is the impossible event. That's why plot is 0. So answer of bit number 1 to observe at least one p is 1 because it takes all the values of variable. Bit number 2, probability pod will contain at most 5 p's. When I say at most, it is maximum. So you have to start with the given number and come down 5, 4, 3, 2, 1. When there is at least, start from given number and go up till possible. That is the concept of at least, at most. So probability of xt less than equal to 5. Now, if I want to make this direct calculation, I have to add probability 1, 2, 3, 4, 5. I can reduce this calculation by result of complement 1 minus opposite of this. xt opposite of less than is greater. It is equal here, so equal not comes in the complement. So xt greater than 5 means what? Only one number, that is 6. Because I repeat my experiment for 6 p's. So my last value of xt is 6. So I replace 6 in the formula and I get answer of this probability. So finally, I get 0.882. So this is the way of performing calculations with truncated binomial random variables. What is third bit? Probability, chance, pod contains exactly 3 p's. Very simple question. Probability xt equal to 3. In the original formula, replace x as 3 and simplify. That is the answer of your third bit in under A. After this, we proceed ahead. B number, average number of p's. That means expected value of truncated binomial. This is the formula of truncated mean. Replace the numbers, simplify. Bit number C, standard deviation of number of p's in a pod. This spelling is wrong. It will be p's. It is under root of variance. Put the variance formula. Replace the numericals. Simplify. You get answer 1.1179 at the root of this quantity. Now, this is the important in the question. Draw the sketch of PMF for given random variable. Now, to draw the sketch of PMF, we have to calculate probability at each value of random variable. In this example, random variable begin from 1, 2, 3, 4, 5, 6. So we get probabilities for each calculation. Truncated random variable, taking value 1 to 6. I calculate numerator first. 6 choose x, 0.7 raised to x, 0.3 raised to 6 minus x. First calculation, replace x equal to 1 here, at this place, and simplify the term. This is the probability. Repeat for x equal to 2, here, and simplify. So you get the numerator at each value of x. Second column is your probability of truncated variable. This is px, which is from this column, 1 minus q raised to n. This is the fixed number for all the values. Q is 0.3, 0.3 raised to 6. Subtract from 1 and divide each of these number by this, you get this answer. You can make a total of this column. It should be compulsory 1 because this represents the PMF. After this, I have graph paper. Y-axis is the probabilities. X-axis is the value of truncated random variable 1 to 6. Now you can see easily the graph. This is the point where probability is maximum. So according to definition in paper 2, what is a mode? It is that value of x where probability maximum than other. So at x equal to 4, probability is large. So for this example, my value of mode is 4.